Humanity has an energy problem. The more we evolve, the more power we need. Eventually, even a planet's worth of resources won't be enough. That's where the concepts like Dyson Sphere comes in, a massive structure built to hijack the power of a star. These are all the possible ways to harvest a star energy. Dyson Swarm. This concept represents the most practical and scientifically plausible version of the megastructure, consisting of a vast constellation of independent satellites or mirrors orbiting a star. Instead of a solid shell, these individual units would intercept a fraction of the sun's energy and beam it back to collectors or habitats elsewhere in the system. Construction could begin incrementally, with each launched satellite providing immediate power and funding the creation of the next. Over centuries, the density of the swarm would grow until it effectively captures nearly the entire luminosity of the star. Star Lifter. This structure is designed to physically extract matter directly from the star to be used as raw material for further construction. By using magnetic fields or thermal heating to create massive solar flares, a civilization can siphon off hydrogen and helium from the star's outer layers. This process not only provides an almost infinite supply of building materials, but can also extend the star's lifespan by reducing its mass and slowing down its nuclear fusion. It turns the star into a cosmic factory, providing both the power and the physical resources needed to expand across the universe. Dyson Shell. This is the classic interpretation of the idea, imagining a literal solid sphere of matter that completely encloses a star to capture every single photon it emits. While it is the most famous version in science fiction, it faces immense engineering hurdles, specifically regarding the structural integrity and the incredible tensile strength needed to keep the sphere from collapsing into the sun. If such a feat were possible, the interior surface could theoretically provide billions of times more living space than the surface of a planet. However, the lack of gravity on the interior surface and the vulnerability to meteoroid impacts make it more of a theoretical limit than a practical construction goal. Dyson Bubble. This variation solves the structural stability issues of a solid shell by using light sails that are pushed outward by solar radiation pressure. Each component of the bubble is essentially a stationary statite that hangs in space, balanced perfectly between the inward pull of gravity and the outward push of the star's light. Because these sails are not in orbit, they don't risk colliding with one another in a complex web of paths. This allows for a static, non-rotating structure that can remain in place indefinitely as long as the star continues to shine. Matrioshka Brain. This is a specialized, multi-layered Dyson structure designed not just to collect energy, but to use it for massive computational power. It consists of several nested shells of solar collectors, where each inner layer uses the star's direct radiation and then sheds its waste heat outward. The next layer then captures that waste heat to power its own systems, repeating the process several times. This creates a massive computer the size of a solar system, capable of running entire simulated universes or processing the data of an entire galaxy. Dyson Net. This structure is a lighter, web-like configuration designed to tether various energy collectors together using high-strength cables. Instead of solid plates or independent satellites, the net functions as a flexible mesh that can expand or contract based on the energy needs or the physical movements of the star. It represents a middle ground between the rigid shell and the loose swarm, offering a more interconnected way to manage power distribution across the system. Bubble World. This is a specialized form of a Dyson structure designed specifically for habitation, rather than just energy harvesting. In this scenario, a shell is built around a massive gas giant or a star, and the interior is filled with a breathable atmosphere. The outer shell contains the air and heat, while the gravity of the central body keeps the atmosphere layered against the interior walls. It creates an artificial environment of such staggering scale that it could house trillions of people in a single continuous ecosystem. Stellar Engine. This is perhaps the most ambitious evolution of the Dyson concept, where the megastructure is used to move the entire solar system through space. By reflecting radiation back at the star in a specific asymmetrical pattern, the resulting thrust acts like a rocket engine on a cosmic scale. This would allow a civilization to steer their star away from dangerous supernova events or navigate toward more resource-rich areas of the galaxy. It transforms the star itself into a vehicle, ensuring the long-term survival of the species across millions of years.